So this is our work, multimodal foundation models for digital garments. And then we basically want to design a tool that tailors can use to help them with their daily job. For example, like design a sewing pattern to make their make the clothes. And then the way we did it is that we took we want to leverage the world knowledge from existing large language models, and then we want to extend it to generate sewing patterns. And sewing patterns are these, we represent them as 2D like polygon shapes together with the stitching information to describe how are they tied together to make like a draped garment, like here. And then, yeah, so the way we did it is that we first took the sewing patterns from garment code data, which is a procedural garment generated garment sewing pattern data set that contains 120,000 data points, and then we annotate it with image and text, and we also have some editing pairs of sewing patterns that are kind of before and after the editing given the instruction. And then to kind of input the sewing pattern into a large transformer, we need to serialize it into a set of tokens. So we developed like a novel sewing pattern tokenization scheme that describes each panel as a set of drawing commands, and then also the stitching information as the tag associated with each of the ends. Yeah, and then we use our framework and train on the data we collected. And then our result surpasses all the baselines. For example, Surpassing cannot really generalize to this more complex sewing pattern data set, but we can generate simple garments. And also we can do multimodal sewing pattern generation. We can do image to sewing pattern and text to sewing pattern. And we can also put text and image both and generate the sewing pattern out. We can also do some iterative, interactive editing applications. We can taking a sewing pattern into our model together with the text instruction and have an edited sewing pattern output. Yeah, and also our model is faster in terms of generation speed because our tokenizer is pretty efficient. Yeah, thank you.